Hey guys, it's Mr. Riz again. Hopefully the first section went all right. Remember, with the CYUs, you can go back and retake them. So if you didn't get a good grade or didn't get the grade you wanted, you can go back and retake them as many times until the first quiz or test. The first test will be after section 1.4. So you got a while to go back and change that. We're going to do 1.2 now, which is all about linear measure. And the objectives for those, first up, is how to measure a segment or segments. Pretty simple. And the next one, how to calculate with measures. So we're going to be doing a lot with linear measures. Alright, chapter 1's full of vocab, so let's get the vocab started. First off, we need to talk about betweenness of points. Between any two points on a line, there is another point. So that means basically no matter how straight or how small the distance between the 2 points is, you can always put another point in between them. Alright, next up, the line segment. A line segment is a portion of a line with 2 endpoints. Now here's the big thing. Make sure you guys know this. A line, if we say AB is a line, we put arrows. But if it's a line segment, we say AB and we just put a line over it. Alright, so a line segment is something that we can actually measure because it has a distance it has an end point, it has a start and an end. Okay, next we need to talk about what it means to be between in math sense. Alright, point A is between two other points, B and C. A, B, and C are on the same line. Well, if they're on the same line, they're collinear. So that means AB plus AC equals BC. Now this is another big thing called segment addition. You might want to write that down. Segment addition. It's a big thing we'll talk about in a couple sections. Segment addition. Alright, the next thing we're going to talk about, we're not going to use a lot, but we'll talk about construction. Construction is the method of creating geometric figures without measuring tools. There's actually some activities that we might do throughout the year, especially towards the end of the year, where you can actually create 90-degree angles with only a pencil and a string. That's all you need. Or create congruent figures with just string and a compass maybe. Alright. Moving on then, the next part of the vocab. We got congruent segments. Now this is a big thing. Congruent segments are two segments with the same measure. Now what we use to use congruent, we use this symbol here, congruent. So if we know that the measure of AB, line segment AB, is equal to the measure of line segment XY, we can just simply write AB is congruent to XY. So we'll be doing a lot of those, especially in chapter 2. Alright, now just some vocab to think about. Congruent segments can be illustrated by real-world examples. Consider opposite sides of this book, or in this case, the iPad. The lines are the same size. Write some real-world examples of other congruent segments. So try to think of some. You might want to pause the video now. And when you're ready, press play. We can talk about railroad tracks. Each side's the same length. If not, the train would kind of ride a little weird. And the edges of a picture frame, or those are pretty square. Just make nice right angles then. Okay, moving on with the notes. We're going to talk about measuring line segments. Alright, measuring line segments. What we're going to do is use this model here. We got a ruler and measure the line segment. Now, I know this may seem easy, but you'll be surprised how many students actually miss this. So the first thing we need to do is look at the ruler. Each inch is divided into, we'll see, we got halves, quarters, we got eighths. So that's, now if we look, we're going to pick eighths because that's where the measure was on. We could go through and technically that's 16ths. Alright, so let's put that down. Each inch is divided into 16th. If we look at point B is closer to the 1 3/8 inch mark. So AB is about 1 3/8 inches long. Now what we can do is talk about precision here. Precision is something that used to be a bigger deal in geometry, but now it isn't. It's kind of phased out. We can see, we can guess it's about 1 3/8 inches long, but that's because our ruler only goes so far. If our ruler was more exact, we probably could get a more exact measurement of the length. But we can only go as far as our ruler, and our ruler says it's about 1 3/8. So we can say it's about, but we don't know exactly if it's 1 3/8. Okay, next, what we're going to do is model the three types of methods to calculate measures of a line segment, and then write an example. So first one, we're going to talk about measuring by adding. And so that's done like so. We can use a number line where two segments that are equal to, or two segments that are equal to a longer segment. So if we try to think of it, we got a number line. Whoa! Let's do this. We got a number line here. Let's put two segments here. So here's one segment, L and M, and we got another segment, M and N. So we can measure, we can say that LM plus MN equals LN. So we can figure out how long LN is by adding the two together. Alright, next what we can do is measure by subtraction. Alright, and so an example of that is a number line again where a smaller segment is subtracted from a larger segment. So we're going to draw another number line that looks just like the last one. Alright, X, Y, and Z. That's a great X. Alright, so this is saying, like, what if we knew this whole length here? So if we took XZ, the big length here, and we subtracted YZ. Excuse me. Well, what's left over is XY. So we can figure out what the little small piece is by subtracting. Now the next one, finding measurements by writing and solving equations. This one's best solved through an example. So let's suppose that. Alright, so say we have two segments. We have ST, which is 4x, and SV, which is 5x minus 3, and we know TV is 15. So let's draw what that looks like. We got a segment here, and notice how S is in both of them. That means S is in the middle. And we got S to T for the first one, and S to V for the second one. And now this is 4x, this is 5x minus 3, and this whole length from here to here is 15. Now if we want to figure out how big each of the smaller ones are, what we could do is just make an equation. Since we know this and this added together equals the whole length, and the whole length is 15, what we can do is add those together. Well, 4x and 5x make 9x, so 9x. We still got this minus 3 though, so minus 3 equals the whole length, which is 15. Now algebra 1 time to solve, we'll add 3 to both sides, so we get 9x equals 18, so x equals 2. What we can do is plug that back in. So ST is 4x, or 4 times 2 is 8, and what's left over? SV, you can solve it, SV equals 7. These are going to be a lot of problems that you guys will deal with, so make sure you guys know how to do that type of problem. That's a good example to go back to if you need help. Alright, so that concludes this section. If you need help, again, watch this problem. A lot of the problems that you guys will be doing are going to be like this, and this should be actually a piece of cake problem for you. Alright, if you need any help, ask me or watch the video again, or let's do this. You have a CYU at the end of this section, and then we'll be moving on to 1.3. Alright, good luck.